A particle of mass 2 kg is projected up an inclined plane, making an angle of 20 degrees with the horizontal, with a speed of 6 meters per second. The particle comes to rest after 4 meters. Find the deceleration of the particle. 2. Find the frictional force F and normal reaction. And hence deduce the coefficient of friction between the particle and the plane. The particle then starts to move down the plane with acceleration a meters per second squared. Find A and the speed of the particle as it passes its starting point. Now we have a situation like this. The body is projected up an inclined plane, and the inclined plane is 20 degrees to the horizontal. So we are told that as it moves from this place, u is 6 meters per second, and it's projected up the plane. Yes, we are told it's 2 kg. As it projects up the plane, from here it stops at a point which is 4 meters. We are asked to find the deceleration of the particle. The deceleration, let's find that from A. So we can find that using v squared equals u squared plus 2as. So what is our v? 6. No, what is our v? 0. V is 0. So we can now say 0 equals 6 squared plus 2as. And what is our s? 4. Therefore, A is equal to minus 36 over 8, which is minus 4.5 meters per second squared. So, deceleration is 4.5 meters per second squared. The next question says that you find the frictional force F and the normal reaction R. So from here, what will be the normal reaction? We have done that one in resolution of vector. It will be like this. The normal reaction will go like this. Mg 2 times G. And we have this. So, normal reaction so this one is 2G cos 20 degrees. We have 2G sin 20 degrees. So this one is equal to n. If you look at it, since there is no other force acting on it, so it's equal to 2 times 9.8 cos 20. So the total force affecting the motion of the body or the particle is frictional force plus components of weight down the plane. Total resisting force. You can get that one now. So let me get the normal reaction. So normal reaction is 18.42 Newton. So total resisting force is the frictional force plus component of weight down the plane. And what is total resisting force? Mass times the deceleration. Therefore, NA is equal to mu n plus mg sin 20 degrees. You can see. And here plus F. That is the total resisting force. So what is our NA? That is 2 times 4.5 here. 4.5 is equal to mu times 2 times 9.8 cos 20 plus 2 times 9.8 sin 20. So we can now get this. Let's clear through by this. Let's remove that one. Then our coefficient of friction will be 4.5 minus 9.8 sin 20 over what you have gotten. Okay, 9.8 cos 20, and that will be 4.5. That is 0.125. That is 0.125. And F, I can find F straight by either subtracting this from this place, this one from this one place, and that will be 2 times 4.5 minus 2 times 9.8 sine 20 degrees. Or I multiply straight with this. So that will be 2.3 Newton. We are asked in the second part to find the A and the speed if it decelerates. Since we have gotten this now, we can now see that the frictional force will go upward in this instance. The frictional force will go upward. 2g sine 20 will act downward. And this will now be the force that will help us to move the body down. Let's see what it will be like. Since you have known what N is, so A down the plane, it will be 2 total force down the plane, total force down the plane divided by N. What's the total force? Now we have 2g sine 20 minus mu n, and we know that still give us this divided by n, so which is equal to 2 times 9.8 sine 20 minus 2.3 over 2, and that gives, so that is 2.2 meters per second squared. We are also asked to find the speed of the particle as it passes through the starting point. That is also easy since we know the distance. The distance is 4 meters. So with that, we input it into our, is a parameter for us, and we input it into the formula. Let's see. So velocity or speed at starting point is v2. Now s is still the same, 4 meters. We are told. Therefore, and we know that u in this instance is 0. So we know that v2 squared will be equal to u squared plus 2as. And what is our s? 4. So we now have v2 squared will be equal to 0 plus 2 times 2.2 times 4. So v2 will be equal to 4.195 meters per second, approximately 4.2 meters per second. So that will be the velocity on its return to the initial point. So that's the velocity on its return. Figure 22.10 shows a boy on a simple playground slide. The coefficient of friction between a typical clothed child and the slide is 0.25. And it can be assumed that no speed is lost when changing direction as b. The section AB is 3 meters long and makes an angle of 40 degrees with the horizontal. The slide is designed so that the child starting from rest stops at just the right moment of arrival at C. 1. Draw a diagram showing the forces acting on the boy when on the sloping section AB. Calculate the acceleration of the boy when on section AB. Calculate the speed on reaching B. Find the length of the horizontal section BC. Find the speed of the horizontal section BC. The question says that we should show the forces acting on the boy when it is on the section AB. Let us use this to represent the boy. And this is his weight. Here, this is the normal reaction. So this will be N, and this is mg cos 30. No, cos 40 degrees. So this one also will be mg cos 40 degrees. Down the plane, we have mg sine 40 degrees. The frictional force acts against this. We have F, which is mu times n, which is 0.25 times mg cos 40 degrees. So these are the forces acting on the body. We are now asked to find the acceleration of the ball when on the section. The acceleration A will be net force over mass. And what is the net force? It's mg sine 40 minus mu n. That is mg sine 40 degrees minus 0.25. Yes, this is 0.25, please. 0.25 mg cos 40 degrees divided by n. And that's going to give us g into sine 40 minus 0.25 cos 40 degrees. So that's our A. And what's our A now? Our A is 4.423 meters per second squared. That's our A. So the next question says that you find the velocity at this point. We know our s to be 3. And then here, u is 0. V at this point is what you have to find. So at the distance, s is 3 meters. A is 4.423 meters per second squared. Therefore, v squared equals u squared plus 2as, which is 0 plus 2 times 3 times 4.423. And that is 26.54. So v at that point will be 5.151 meters per second. We are now asked what will be the length of BC so that the velocity here will be equal to 0. The first thing is for us to calculate the retardation at this point. And from the previous section, we know that retardation will be equal to 0.25 times g. If you work it out, that's it, 0.25 g. And it's going to be 2.45 meters per second squared. And since it is acting against the motion, we can now find our s2 here. So, what is our v2 here? 0. So v2 squared is equal to v squared plus 2as. And in this instance, a is negative, so 0 will be equal to 5.151 squared plus 2 times s times minus 2.45. Therefore, s will be equal to 26.54 divided by 2 times 2.45. And that is 5.416 meters. So for the body to come to rest at C, this is the distance from B to C. We have an interesting question here. A 5 kg block lies on a rough horizontal table. The coefficient of friction between the block and the table is 0.2. The block is attached by a light inextensible string which passes over a smooth pulley to a mass of 2 kg hanging freely The 5 kilogram block is 1.5 meters from the pulley, and the 2 kilogram mass is 1 meter from the floor. The system is released from rest. Find 1, the acceleration of the system. 2, the time taken for the 2 kilogram mass to reach the floor. The velocity with which the 5 kilogram mass hits the pulley. Here, we have a very interesting question. To find the acceleration, we know that frictional force will act against this place. And that will be, and the normal reaction here is 5g. Where g is 9.8 meters per second squared. So, this will be 0.2 times 5g. Where 0.2 is mu, coefficient of friction. It acts against this. And we have this acting downward. We have this 2g. Let's make this one tt. Now, let's now work out the acceleration. We can now say 2g minus t is equal to 2a. T minus 0.2 times 5g is equal to 5a. So let's add the two. We have 2g minus 0.2 times 5, 1. So minus g is equal to 7a. So a will be equal to g over 7, which is 9.8 over 7. And that is 1.4 meters per second squared. So very easy and straightforward. The only force that acts against this thing is this. Since you have gotten that, we are now asked to find the time taken for the 2 kilogram mass to reach the floor. The distance is, now, the distance for this one is 1 meter. A is 1.4 meters per second squared. So, for time, and initial velocity is 0. So u equals to 0. Therefore, t, we can use t, s equals ut plus half a t squared. And that is 0 times t plus half times 1.4 t squared. And s is 1. So 1 equals to 1.4 over 2 t squared. So t will be equal to 2 over 1.4 t squared, sorry. So t will be equal to root of 2 over 1.4. So let me get that. So this is 1.2 seconds. Approximately 1.2 seconds. Approximately. We have got to the second part. So we have now seen that from this place to 1 meter here, the 5 kilogram mass will also spend 1.2 seconds. So we are asked the velocity. We see the 5 kilogram mass hits the pulley. The velocity of this one when it gets here is also the velocity of this one when it gets here. So let's first of all calculate the velocity after distance 1 meter. And let's see. So we can say v squared equals u squared plus 2as. And that is v squared, here is v at this point, that's what I'm referring to, is equal to 0 plus 2 times 1.4 times 1. So v is root of 2.8. Let me get that. That is 1.673 meters per second. So the velocity at this point is 1.673 meters per second. At this point, this force no longer acts. This force no longer acts. Therefore, the component of t is 0 at this point. T equals 0. So the only force that will act now is 0.2 times 5g. So in this instance, A will now be equal to minus 0.2 g. And that is 1.673 1.96 meters per second squared. That's our A. So, and our V at this point is 1.673. So, and the distance from here to here, our F2 is 0.5 meters. So, the velocity with which it will reach this place, let's call that on V2. So, V2 squared is equal to V squared plus 2AS. And it's going to be 2.8 plus 2 times minus 1.96 times 0.5, and it will give me 2.8 minus 1.96. That is V2 squared. So 0.84. So V2 will be equal to square root of this 0.917 meters per second. So the velocity with which this 5 kg will meet this pulley here is 0.917 meters per second. A block of mass 1.2 kilograms is placed on a rough horizontal surface. The block is pushed by a force P, which is at 20 degrees to the horizontal. The block remains stationary. Draw a diagram showing all the forces on the block. The coefficient of friction between the block and the surface is 0.4. The force P is increased until the block begins to slide. 2. Find the value of P when the block is on the point of sliding. Now this is what you have. For the first part, this block, P comes here. We have mg and we have n. The reaction from the surface. Because P is going like this, F will come like this. The frictional force can vary from 0 to mu n. But since the body is stationary, we don't know the value of F. And this is P. So, what we have now is, we are going to have a situation like this. P will come down and increase the value of n. And we are told that this is 20 degrees. So this is 20 degrees here. So this is how the diagram will be. We have mg, and we have n, and we have f. So that is the diagram for the force acting on the body. The second part now tells us something, that this F continues to act until the body begins to slide. And as in the body begins to slide, and that is, we have the bending motion at that point, which makes F to be equal to mu n, because at that point F has increased and gotten to the point of mu n. We are now asked to find the value of P. So for this second part now, we have something like this: n, P, mg, and f, and this f is 0.4 n. So using resolution of vector, you can use triangle of vectors. Since you know the direction that the sum of this will act, you can use direction. So let's see. A resolution of vector. P cos 20, yeah. P cos 20 will be equal to f, which is 0.4 n. That one is clear. We can now see that n is equal to mg plus p sine 20 degrees. You can see. Therefore, for this one, and m is equal to 1.2, g is 9.8. So we can now see 0.4 mg plus p sine 20 is equal to p cos 20. And then I can now see mg plus p sine 20 is equal to 2.5p cos 20 degrees. So mg equals to p into 2.5 cos 20 minus sine 20 degrees. So p will be 1.2 times 9.8 over 2.5 cos 20 degrees minus sine 20 degrees. So let's find that. So that gives me 5.86 approximately. And if I want to use triangle of forces, it's also very easy to do. So I can find this one here, that is R of N and F. I can put it here, and the direction here will be R times 0.4 times minus 1, 0.4, R times 0.4. So this one is 21.8. 21.8 degrees. So with this, I can get the value of P conveniently. How do I do that? R 21.8, P 20 degrees, and mg comes down. So I can use Lami's theorem, and I can use triangle of forces. Let's see what Lami's theorem will be. So this one will be 20 plus 21.8, that's 21.8. And this place is 90 degrees. So everything here is 131.8. From here to here is 70. And from here to here is 180 minus 21.8. And this is 158.2. So you can see, I can just say, and this is 1.2 times 9.8. I can now say P over sine 158.2 is equal to mg over sine 131.8. So P will be equal to mg sine 158.2 over sine 131.8. So you can see P equals to 5.86 Newton. Now, if I want to use triangle of forces, since I have known, it's always good, you learn the skill of reducing your forces to 2 or 3, when you know the direction. Now I can just find it like this. Here, mg, and I also have P, and I have R that comes like this. Now, from this place, I can see that this one is 20 here. So the whole angle here is 110. Look at this one, it's 21.8 to the vertical. So this place is 21.8. And this place too is vertical, downward. So 21.8 and this one is 21.8. Alternate angles. You can see. So from here, I can now get this place. This one plus this one is 131.8. And every angle in a triangle is 180. So this angle here is 48.2 degrees. Now, what I need to find is P now. So I can now say sine P over sine 21.8 is equal to mg over sine 48.2. Therefore, P will be equal to mg sine 21.8 over sine 48.2. And that is 1.2 times 9.8 times sine 21.8 over sine 48.2. And that gives, I believe the same thing like this. And now it's still the same. 5.86 Newton. So it's very, just learn all the techniques depending for your use any point in time. A box of weight 100 Newton is pulled up at a steady speed across a rough horizontal surface by a rope which makes an angle alpha with the horizontal. The coefficient of friction between the box and the surface is 0.4. Assume that the box slides on its underside and does not tip up. Find the tension in the string when the value of alpha is 10 degrees, 20 degrees, and C 30 degrees. 2. Find an expression for the value of T for any angle alpha. 3. For what value of alpha is T minimum? So we have a situation like this. Across the rough surface by a rope which makes an angle alpha. So this is the body. And this one is 100 Newton. And we have a body here. See. And it's making angle alpha with the horizontal. We have frictional force, which is mu n, and mu is 0.4, and the reaction n, normal reaction is the same thing as, no, the normal reaction is n. We have different values for normal reaction, and T will affect it. Sorry, the angle will affect it. So which at the same time will affect our frictional force. For the body that is now sliding, it means that frictional force is mu n in this instance. Let's now work it out. Let's find the expression for the value of T for any angle, and from there we'll be able to get this. Let's do it like that. Now T cos alpha is equal to F, which is mu n, and 100 Newton is equal to n plus T sine alpha. Since we are trying to find the value of T, let me make this one T cos alpha, T sine alpha here. So T sine alpha will be equal to 100 minus n. 100 minus n. And we know what our n is. N is T cos alpha divided by 0.4. T cos alpha divided by 0.4. From here. So let me now make it straight. So I have T sine alpha is equal to 100 minus T cos alpha by 0.4. Let me multiply 2 by 0.4. I have 0.4 T sine alpha plus T cos alpha will be equal to 40. Then T will be equal to 40 over 0.4 sine alpha plus cos alpha. So since I have gotten this, I'll be able to get this ones easily. So when alpha equals to 10, T is equal to 40 over 0.4 sine 10 plus cos 10. And what will that give us? 7.94 Newton. Now, when T equals to 20 degrees, when alpha equals 20 degrees, I'll just input it here, and it's going to be, that is 37.16 Newton. When it is equal to 30 degrees, it's 37.52 Newton. So very easy. Now we also ask, for what value of alpha is T minimum? So here we just need to use our differentiation integration, our calculus, and we know that for minimum T, the alpha will be equal to 0, and you can use logarithm or your normal differentiation of fractions. Now let's work this out. The TD alpha will be equal to 0.4 sine alpha plus cos alpha. So this one, the 40 dt, the alpha is 0, minus 40 into 0.4 cos alpha minus sine alpha over 0.4 sine alpha plus cos alpha squared. And we know that from this place it will be equal to 0. It will be equal to 0. Now, so from here, we only need the numerator. This one is 0 already. And so this place 2 will give us 0. We don't need this place again. So we can now say 40 into minus 40 into 0.4 cos alpha minus sine alpha equals 0. So this one has nothing to do there again. So we have 0.4 cos alpha, that is divided through by minus 40 with 0, minus sine alpha equals to 0. Therefore, sine alpha is equal to 0.4 cos alpha. Divide through by cos alpha. It means that tan alpha is equal to 0.4. And if you see, this 0.4 is mu. So the angle we are finding is the angle of the friction for the minimum force, for the minimum tension. So alpha is arctan 0.4, and that is 21.8 degrees. So that's the answer. So for minimum tension, our angle will be 21.8 degrees. You can also work it out and find the minimum force, minimum tension. If the least force, which will move a body up a plane of inclination alpha, is 2 times 5 times the least force, which will just prevent the body sliding down the plane, shows that mu, coefficient of friction, is equal to 3/7 tan alpha, where mu is the coefficient of friction between the body and the plane. So this is what we have. We have a body like this, and this is the plane, this is the body, and this is engine. And the least force which should move a body up a plane, if the inclination is 2 times 5. So let's see.
Just give it
Just leave it. So now we have n. We have ng cos alpha. This is alpha. And if the body is to move, is to be prevented from coming down, that is sliding, frictional force will go up here, and the force here will hold it. F, this is frictional force. This should be mu n. And we have another component down, which is ng sine alpha. So this P here, this F here, let's make it P. To prevent it from coming down, we have P plus FR will be equal to mg sine alpha. And what is FR? Mu n. And what is n? Mg cos alpha. So we have P plus mu mg cos alpha is equal to mg sine alpha. So this P will be equal to mg sine alpha minus mu mg cos alpha. Now, for the body to move up, this frictional force will now act downward, and P will be like this. So we have, so in this instance, let me call this one Q, FR. So Q will be equal to mg sine alpha plus FR this time around, because the body is stopped from sliding. The body is down ahead, is being moved up the plane, and that is mg sine alpha plus mu mg cos alpha. And from the question, we realize that Q is equal to 2.5 P. Therefore, ng sine alpha plus mu ng cos alpha is equal to 2.5 ng sine alpha minus mu ng cos alpha. And what we are trying to find is mu. Let's divide through by n. Therefore, I can say sine alpha plus, okay, g sine alpha plus mu, okay, let me divide through by g again. G. So I can now say sine alpha plus mu cos alpha is equal to 2.5 sine alpha minus 2.5 mu cos alpha. Now, so let me bring this here, let me bring this one here. So I have 3.5 mu cos alpha is equal to 1.5 sine alpha. Dividing through by cos alpha, I have, okay, let me, mu will be equal to 1.5 sine alpha over 3.5 cos alpha. and that is 3 over 7 times alpha. So we have already proved what we are required to do. A box of mass 410 kg is placed on a rough inclined plane of slope at sine 9 over 41 and mu 0.2. A rope is attached to the box and the direction of the rope makes an angle at sine 3 over 5 with the upper surface of the plane. If the tension in the rope is T Newton, find the limiting values of T for which the box remains in equilibrium. We have a situation like this. So, we have alpha, and this box, we have another, so we have T, but we know the weight of the box, that is 410 times G, and G, let's take G to be 9.8 meters per second square. So let's call G, this one beta. We have two situations. See, the body will be in equilibrium if T handles it in such a way that it is about to slide down, or when it is about to move up. So it varies from when frictional force acts downward to when frictional force acts upward. So when the frictional force is acting downward, T will be minimum. When the frictional force is acting upward, when the frictional force is acting upward, T will be minimum. That is, the body is about to slide down. When F frictional force is acting downward, that is, the body is about to move upward. So we have two regions for the forces, for the value T. Now, we are given this situation that mu here is 0.2. For alpha, at sine 9 over 41. For beta, is at sine 3 over 5. So we can find all these other values we need. Let's start. When F is about, when F wants to slide down, but T is just to hold it from sliding down, F will be upward. F will act upward. That is, if T is just to hold the body from sliding down. So it will vary from that one. And then after that, it will now increase until F now starts coming down. Let's see. We have mg cos alpha. And we have n. We have this. At the same time, we have mg sine alpha. Like that. So for the first condition, F acts upward. Let us resolve everything along the plane. It will now be like this. We are going to have a situation where our forces will be like this. We have mg cos alpha n c. We also have t sine beta, and upward like this. We have t cos beta. We have mg sine alpha. Please take notes. We have mg sine alpha. This is the first. Yes. These are the constant forces. But F is the one that changes and varies from place to place. So which now affects the value of T. Now we are saying that if the tension T is to prevent the body from sliding down, F will be upward. F, and you know what our value of F is? F is mu n. Now, we are now asked to find the value of T for this situation. Now, to prevent the body from sliding down, frictional force or friction acts upward. Therefore, mg sine alpha will be equal to F plus T cos beta. And we know what our f is. F is 0.2 n plus t cos beta. For our perpendicular to the plane, we have n plus t sine beta is equal to mg cos alpha is equal to mg cos alpha. So we know what our n is, and then let's now work it out to find the value of t for this side. Yes. So I have 0.2 n plus t cos beta is equal to mg sine alpha. Let me multiply this place also by 0.2, or multiply this one by 5 to make it same. So let me make it n plus 5t cos beta is equal to 5 mg sine alpha. So subtracting this from this place, I'm going to have 5t cos beta minus t sine beta will be equal to 5 mg sine alpha minus mg cos alpha. So you can see. So from here, I can work out my t. T will be equal to mg into 5 sine alpha minus cos alpha over 5 cos beta minus sine beta. Now let's go back to the values given to us. We know for this angle sine alpha is 9 over 41. So if I just draw the triangle like this will be alpha 9 41. So what will this place be? It will be square roots of, let me see. So this place will be 40. You see, this place will be 40. So for me, cos alpha is equal to 40 over 41. You can see that. Now let's work for, so cos beta, sine beta is 3 over 5, cos beta is 4 over 5. So from there, I can find my t, which will be equal to, so after getting this, I substituted here. So t equals to 144.12 Newton. That is to prevent the body from going downwards. Now, if at a point t is increased to the extent that the body now starts sliding up at constant velocity, it means that this f will have to act downward. And so I will have mg plus f mg plus f, because it will now be equal to t cos beta. Will now be equal to t cos beta, and I will now have it like this: t mg sine alpha will now be t cos beta minus f. Therefore, mg sine alpha will be equal to t cos beta minus f. You can see. So it will be equal to t cos beta minus f. And that is t cos beta minus 0.2 n. You can see. So what do I have here now? I'm going to have t cos beta minus 0.2 n will be equal to mg sine theta. So you can see, just because f has changed its direction now, so the force will be increasing until it gets to this one. So let's work it out. So let me multiply this one by 5 again. So I have 5t cos beta minus n is equal to 5 mg sine alpha. So what do I have now? Adding these two, I'm going to have 5t cos beta plus t sine beta. You know, I added to eliminate n. Is equal to 5mg sine alpha plus mg cos beta. So from here, I can now factorize. So t into 5 cos beta plus sine beta will be equal to mg into 5 sine alpha plus cos beta. So t will be equal to 410 times 9.8. And what is 5 times sine alpha? That is 45 over 41. What is cos alpha? 40 over 41 divided by what is cos beta? So that I am going to have 20 over 5 plus sine beta 3 over 5. So we are going to have t to be equal to 410 times 9.8 times 80 over 41 times 5 over 23. So let's see what that gives us. T will be equal to, so t will be equal to 410 times 9.8 times 85 over 41 times 5 over 23. So t will be equal to, if the body is trying to move upwards, so and the value is 1810.87 newton. So t varies from 144.12. T varies from 144.12 to 1810.87 newton. So .87 newton. So that is the value for t for this question. So it will look static, it will look at be an equilibrium when t is 144.12. The frictional force is upward then. So when it is now, after some time, it will increase and increase and increase as t is increasing. So at the point, the frictional force will move down, and then it will, once it now moves down, t will now be able to move the body upward. The frictional force is acting against t at that time, but when it is holding it, frictional force is supporting the tension upward. So that is it. So in the initial stage, friction is helping t to hold the body. After some time, when the body now starts to move, friction is already down against it. That is why we have this situation. So compare this to the last question, and it will be more clearer. Now in this question, we have a diagram. A block is placed on a plane, smooth plane. So in this place, we have to disregard friction. And the plane is 40 degrees to the horizontal. The mass of the block is 1.5 kg. And the plane is used to support it at the other end, passed over a pulley. Now we have this question. It says, when the bucket is empty, the system is in equilibrium. Find the mass of the bucket. I like to resolve it along the plane. Along the plane, this is the plane. Let's have t here, and we have t here. So this box is in equilibrium with t acting up like this. We have mg cos 40, and we have mg sin 40 degrees. And this same t for this other body is carrying up the bucket. This one, N1G. Therefore, we have from this place that T equals Ng sin 40. Here N is mass of block. At the same time, T is equal to M1G. Here m1 is mass of bucket. Therefore, we can now say fine n and n is equal to 1.5. 1.5 g sine 40 is equal to m1 g. So m1 is equal to 1.5 sine 40, which is 0.964 kilograms. So the mass of the bucket is 0.964 kilograms. We are now told that if the mass of the bucket is increased to 1.7 kilograms by pouring water inside, that we should find the acceleration of the system. The acceleration of the system. Here now, we can see that T is now equal to 1.7 g. And what does that mean? It means that 1.7 g, because T here will be equal to T here. Sorry. Now, this one now becomes 1.7 g, and this one is 1.5. Therefore, I have to make an equation like this. Along this plane like this, I have T. Therefore, T minus n g sine 40 is equal to m a. And I also have m1 g minus t is equal to m1 a. I know what m is, I know what m1 a is. M is 1.5, m1 is 1.7. Therefore, adding this to I have m1 g minus mg sine 40 is equal to n plus m1 a. What is m1 a? m1 1.7 g. What is n? 1.5 g sine 40 is equal to 3.28. So the acceleration of the system, that's what I'm trying to find now. So I have this one to be equal to g into 1.7 minus 1.5 sine 40 over 3.2 is equal to 8. So the acceleration of the system will be 9.8 times 0.758 divided by 3.2. So that is 2.253 meters per second square. So that's the acceleration of the system. So here, the third one says, when the bucket has traveled 0.8 meters, it reaches the ground and the stream goes slack. Calculate how much further the block will move before it comes to rest. So the system will have a common velocity, and the velocity when this one has moved 0.8 meters, that's what we have to find. And after finding that, we find the final velocity, because after it has gotten that velocity, this tension ceases to act. It has gone slack. So let's get that velocity. When bucket travels 0.8 meters, v will be equal to v squared will be equal to u squared plus 2 times 2.253 times 0.8. So v will be equal to, so the velocity at that point will be equal to 1.9 meters per second. So the velocity at that point, when this has moved and touched the floor, their common velocity will be 1.9 meters per second. And at that point, since T is no longer acting on it, the acceleration A for this block, nu acceleration for the block will now be equal to g sine 40, which is 9.8 sine 40, and that is downward, and that will be equal to that will be equal to 6.3 meters per second square. Now, the motion, the further distance, let's call that S2. Further distance traveled by block. Traveled by block. So we can get that from our equation of v square equals u square plus 2as, and that will be 0 equals 1.9 squared 2 into 6.3 s. So s will be equal to 1.9 squared divided by 12.6, and that will give me 0.287 meters. So if you travel further with a distance of 0.287 meters up the plane,